So to summarize, we know the x-intercepts are just going to be m and n. The y-intercept is the product of a times m times n. The equation for the x-symmetry is still x is equal to m plus n divided by 2. If a is positive, it opens up and has a minimum. If it's negative, it opens down and has a maximum. So we can, just by taking a look at the equation, figure out what these details are. If I'm looking at this equation and it wants me to state the x-intercepts, the y-intercept, the equation for the x-symmetry, and the direction of the opening of the graphs, well, first, I'm going to state the x-intercepts. The x-intercepts are equal to, the m value is -4, the n value is 10. The y-intercept is going to be equal to 1 times -4 times 10. Which is going to give me -40. The axis of symmetry is going to be when x is equal to -4 plus 10 divided by 2. Or when x is equal to 3. And in this case, a is positive, so it's going to open up. For example, B, we can see that I have x-intercepts are going to occur at -6 for m and -9 for n. The y-intercept is going to be when I multiply the -2 for a, the -6 for m, and the -9 for n, which is going to be at -108. The axis of symmetry is going to be when x is equal to -6 plus -9 divided by 2, or when x is equal to -7.5. And this one is going to open down. And for the last example, the x-intercepts are going to occur at 0 for m and 20 for n. The y-intercept is going to be -1 times 0 times 20, but any time that I multiply any set of values and one of them is 0, it's just going to wind up being 0. If either m or n is 0, the y-intercept is going to occur at 0. And the axis of symmetry is going to be when x is equal to 0 plus 20 divided by 2, or when x is equal to 10. This one, because it's got a -a, is also going to open downwards. Sometimes we wind up with a case where it is a disguised a value. If I look at these two equations, when I graph them out on my calculator, they look the same. If I'm trying to figure out why it is that they look the same, well, you can see in the second equation, something looks a little off, and that's because the second set is in the wrong order. If I have 3 minus x, then that is going to be the same as -x plus 3 if I change around the order. Well, in all the other cases, the x's inside the brackets have a coefficient of +1. So if I need to make this positive, I need to remove the negative from x, which means I also have to divide the 3 by -1. And I can see that if I need to change the order of a subtraction, then I'm going to wind up flipping the sign on the outside. I'm going to make whatever the coefficient is at the beginning, if it's negative, become positive. If it's positive, it's going to become negative. So, if I was to do that process for the second equation, I would say that y is going to be equal to -2 bracket -x plus 3 bracket x minus 7. And when I need to divide the negative out of here, it's going to cancel out with the other negative, and I get y is equal to 2 bracket x minus 3 and x minus 7. And now it matches the original graph that I had. So, if I'm doing that process for example 2, then I'm going to see here that I obviously need to flip the order that exists here. If I flip the order, I change the sign for a on the outside. So I'm going to get y is equal to negative bracket x minus 1 and x minus 10. The x-intercepts are actually going to be 1 and 10, and the y-intercept is going to be -1 times 1 times 10, or -10. For example B, I can see that I need to change the order here, which means that I'm going to change the sign for a and make it positive. X minus 4, and then I have 12 minus x. But I can see that I'm also going to need to change the order for the second set, which is going to change the sign for a again and make it negative again. So now I have x-intercepts are occurring at 4 and 12, and the y-intercept is going to occur at -3 times 4 times 12, or at -144. For example 3, I just need to match the graphs to the proper equation on the right-hand side. Well, I'm going to take a look at the equation I have and say that in this case, I'm going to have x-intercepts that occur at 1 and -4. I can also see that my a value is positive, so it should open up. So the only one that I see where it has x-intercepts at -4 and +1 and still opens upwards is going to be graph D. For equation 2, these are in the wrong order, but the first one isn't actually subtracted, so I don't need to flip the sign for the first one. 1 plus x is the same as x plus 1, but 4 minus x is not the same as x minus 4. So the first one I can flip without changing the sign, but the subtraction, when I flip it, I do need to change the sign. And now I see that I have x-intercepts occurring at -1 and +4, and I have a negative a value. Well, if I'm looking for -1 and +4, with a negative a value, or it opening down, that's going to be graph B. For equation 3, I have an a value of positive 1 and intercepts that occur at negative 1 and positive 4. If I have negative 1 and positive 4 and it opens upwards, that's going to be graph C. Oh, sorry, graph A. And last but not least, if I have intercepts at positive 1 and negative 4 and a negative a value, that leaves me with graph C.